Hello, welcome to this video. I'm going to be going over the derivation of the equations for area and perimeter of a circle and for the surface area and volume of a sphere. I'll be using a bunch of calculus, so I don't know, if you have no background in calculus, this might be difficult to understand, but I hope I can explain it well. So we're going to start off with a graph we've all probably seen. This equation, x squared plus y squared equals r squared. And when we graph this, we get a circle of radius r. So now we want to use this equation to find the area of a circle. So how we're going to do that is with integration. So integration finds the area under a curve. So this area here that we want to find out. But the problem is that we need one variable to do that. So we need to rearrange this equation such that there's only one variable. So we can bring x to the other side. So y squared equals r squared minus x squared. And then we take the square root of both sides and we get just y is equal to the square root of r squared minus x squared. So now if we integrate this, we should get this area. But if we graph this real quick, we'll get that it isn't a circle anymore. It's actually just a semicircle of radius r. So if we were to find this area, we'd only get half the circle area. So we have to multiply whatever we integrate by 2. So our integral, this thing, is going to be from minus r to r. You know, we're going from here, which is minus r, to r, since this is symmetrical. We're going to square root it, but we're going to put in our function, r squared minus x squared, dx. And now naturally we're going to put the 2 in front, since our area is going to be equal to 2 of them. So now, how are we going to do this? So if you've heard of u substitution, where we go u is, that's not a u, we go u is equal to some function of x, and then du is equal to the derivative of x times dx. We're going to do something similar to that, but just the reverse of it. So instead of saying u is equal to some function of x, we're going to say x is equal to some function of u, and that dx is equal to the derivative of that function u times du. So for this, we're going to use x is equal to or times the cosine of, oh sorry, not cosine, my bad, or times the sine of u, and then dx is equal to the derivative of or sine u, which is or cosine u, du. So if we substitute these into our equation, well, our integral, we get that it becomes 2, and now the bounds change, so I'm not going to write them for now. And then we have the square root of r squared minus r squared sine squared u, and then this is multiplied by or cosine u du. Now, if we look here, this is a trigonometric identity. If we get squared plus cos squared equals 1, if we multiply both sides by r squared, it's the same as here. So r squared minus r squared sine squared u is actually just cosine squared, well, r squared cosine squared. So this becomes 2 integral square root r squared cosine squared u, or cos u du. Now naturally we can actually just square root this and get rid of that, and then these get cancelled, and then it naturally just multiplies by this, so it becomes the same thing just out of the bracket. So it just becomes r squared cos squared u du. So now we just need to integrate r squared cos squared of u. Now, first of all, we're just going to take that or squared out, since it is literally just a constant. And then cos squared is actually just equal to cosine of 2u plus 1 over 2. That's in the brackets. So this is actually just equal to cos squared, so we can sub that in. So we get 2 or squared times cos of 2u plus 1. Now this over 2, we bring it out into the front, since it is just a constant, du. Now I can integrate this by parts. So we get, it's or squared times cos of 2u, just integrates to sine of 2u over 2. You can just do that with u substitution, but it's really nothing special, so I'll just leave it here. And 1 just integrates to u, so plus u. And now we have to find our bounds. So since x equals or sin u, u is equal to inverse sine of x over or. So now if we sub in, our or and minus or, we'll get that our upper bound becomes pi over 2 and our lower bound becomes minus pi over 2. So we have to evaluate this from pi over 2 to minus pi over 2. So now, if we quickly just evaluate this, we get or squared times sine 2u, which is just pi over 2, plus pi over 2, minus sine minus pi over 2, plus minus pi over 2. Alright, so now sine of pi and sine of minus pi are equal to 0, so you can just ignore them. We get or squared times pi over 2 minus pi over 2, which just equals pi times the radius squared, which would be our circle formula. If you've ever seen it, it is literally just pi or squared. So we get the radius squared and we multiply it by pi. So now we're going to go on to finding the equation for the circumference of the circle. So now we know that the area of a circle is equal to pi or squared. But now we need to find the circumference. The circumference we know is equal to 2 pi or, but let's say we don't know that. So what we can use is an equation I found in a previous video, which is for finding the area of polygons. So if you have a regular polygon, its area is going to be the length squared times s, the number of sides, times cot pi over s still being the number of sides, divided by 4. Alright? So this is for a regular polygon. And now naturally, we know that the perimeter of a regular polygon is going to just be the length times the number of sides. You can probably figure that out yourself. So we're going to say some ratio or is equal to the perimeter over the area. So that means if we multiply it by the area, we just get p on its own. So now let's write this out quickly. So we have L of S divided by, this 4 comes up to the top. We get L squared S cot pi over S. Alright, these L's cancel and these S's cancel. So or is just equal to 4 over L cot pi over S. But now this L is the side length, so if we had a square, it would be this length. But the problem is that as this goes, as S tends up to infinity for our infinitely sided shape or a circle, this L will have to shrink to be infinitely small. So we just get infinitely small 4 divided by infinitely small, which would be 0. It would be undefined if we took a limit. So what we're going to do is we're going to change it from the side length to the radial length. So if we look at a subdivided part of a shape, like a polygon, we get that this triangle. And then there's all the other triangles that then form the shape itself. So if we look at this, we got L, our side length here, and then this is our radial length, essentially OR. So we want to find OR. So this angle here is 2 pi over s. But we're going to cut it in half to make a right angled triangle. So this becomes pi over s. Now we're going to use trigonometry to just get that L is equal to sine pi over s times OR. It's just regular trigonometry. And now we can just sub that into our equation. So we have OR, the ratio of the perimeter to the area, is equal to 4 OR over OR sine pi over s cot pi over s. Now here's the funny thing. Cot of theta is equal to cosine of theta over sine of theta. So this sine and this cot cancel out, since boom and boom, to just leave us with cosine. So OR is equal to 4 over OR cos pi over s. And now we can evaluate this as s approaches infinity. So as s approaches infinity, pi over s approaches 0. And cosine of 0... Oh, sorry. I made a mistake. So this is actually L. So in our little thing, this becomes L over 2. So L is actually 2 sine pi over s OR. And if we just substitute that in the whole way around, so these 2 and 4 cancel, this becomes a 2. Pi over s approaches 0. And cosine of 0 is equal to 1. So we get that our ratio when the number of sides goes up to infinity is actually equal to 2 over OR. So remember, this is equal to the circumference over the area of a circle. So if we multiply this by the area, we'll just be left with the circumference. Now we have our area formula. Our area is equal to pi OR squared. So now if we do 2 over OR times pi over OR squared, we get 2 pi OR, which is the circumference of a circle. That made sense. And yeah, next we'll be moving on to how we do this for a sphere to get its surface area and its volume. So our volume of a sphere can be found using integration as well. So we have our circle function there, y equals square root OR squared minus x squared. And now if we use this, we can actually find the volume of a sphere as well. So you'll probably know this, but a sphere is just a circle revolved over an axis. So we can use that to our advantage. So if we have this, which is our semicircle function here, we can actually, instead of just integrating it like this, we can integrate it, each piece, as a slice of a circle. Like that. well, the slice of a sphere, sorry. Now, to get the volume, which is centimeters cubed, we can actually just add up an infinite amount of centimeters squared, which would be the areas. So, we start by doing that. Instead of adding each section like this as just this, which would be the height, we can add up the area of the little disk we're making, which is just pi or squared, with the radius just being y. So we're actually going to integrate pi y squared from minus or to or, and we're going to do dx. So if we expand this, we just get integrating minus or to or of pi, we'll just bring it out, or squared minus x squared dx. This is not a difficult integral. We can essentially just use the power rules. We get pi times or squared x minus x cubed over 3. And then this is just evaluated from minus or to or. So if we evaluate that, we get pi times or cubed minus or cubed over 3 minus then or squared times minus or squared minus or squared minus minus or cubed over 3. These cancel to make a plus. Then we get pi times these cancel to make a plus. Those cancel to make a minus. So we end up with 2 or cubed minus 2 or cubed over 3. And this equals 4 over 3 pi or cubed, which is the volume of a sphere. Pretty nifty. Now we're going to do the surface area of a sphere. Now this gets slightly more complicated. So you'd think that for the surface area, we can actually just add up all the circumferences, an infinite amount of them. But that doesn't account for the full surface area that we find, because it only accounts for the linear change. So we needed to account for the actual curvature of the function. So that's why we can't just do 2 pi y. We actually have to tack on an extra bit, which would be square root 1 plus y prime squared, which is just the arc length, to get the actual answer. So if we integrate this from minus or to or, 2 pi y times the square root of 1 plus y prime squared dx. So we're first going to figure out y prime. So y is or squared minus x squared. So the derivative of that with respect to x is going to be square root or squared minus x squared. So we just use the chain rule. So the derivative of this bit is 1 over 2 or squared minus x squared and the square root. And that's going to be multiplied by the derivative of the inside, which is going to be, or the derivative of or squared is just 0. The derivative of minus x squared is minus 2x. This 2 and that 2 cancel. We just get minus x up here. So y prime equals minus x over square root or squared minus x squared. And now when we square that, we get x squared over or squared minus x squared. And that would be this bit. So now we can also just substitute in square root or squared minus x squared, and we get our integral now is from minus or to or of 2 pi square root or squared minus x squared times the square root of 1 plus x squared over or squared minus x squared dx. So we can bring the 2 pi out since it's a constant, and we can put these into the same square root or the same radical. So this becomes square root of 2 pi square root minus or to or of or squared times 1, so square root or squared minus x squared, plus this is going to get multiplied by or squared minus x squared, so these and this cancel, and it's just left with x squared, so plus x squared dx. Now the minus x squared and the plus x squared cancel, and the square root and the square cancel, so we're just left with 2 pi times minus or, and we just have to integrate or dx. So if we just integrate this, it's just or times x. So we just get 2 pi or x from minus or to or. Well, from or to minus or. No, from minus or to or. So we quickly evaluate this, and it's just equal to 2 pi times or squared minus, then negative or times or is negative or squared. And this becomes 2 pi times, these just cancel out to make a plus. So 2 pi times 2 or squared, or our surface area of a sphere is just equal to 4 pi or squared, which it is. So all the formulas we found is that the area of a circle is equal to pi or squared. The circumference is equal to 2 pi or. Our volume is equal to 4 over 3 pi or cubed. And the surface area of a sphere is equal to 4 pi or squared. So I hope you learned something. I hope you enjoyed this video, and I hope you enjoyed my explanation of how we can derive these formulas. I don't know. Please like and subscribe. I hope you learned something new, and please go enjoy your day. Thank you for watching, and goodbye.